We present the contact diffusion model CDM. We use only proprioceptive sensor measurements, such as joint torque sensor and an FT sensor at the base. By leveraging a diffusion model, the proposed method tackles the multi-contact point localization problem. Moreover, as shown in the first video, CDM addresses the singularity where multiple pairs of contacts produce identical sensor measurements. The goal of CDM is to generate samples from this multimodal distribution. This is the probability distribution of the contact points conditioned on all past observation and robot surface. However, this type of distribution cannot be handled by a diffusion model because the observation time length cannot be infinite. Therefore, we limit the time length to t. If two contacts occur sequentially though, observations outside the time window contains important information about the first contact. Therefore, to account for the limited observation time window, we modified the posterior to be conditioned on the first contact point location. This results in reduced multimodality compared to the posterior, conditioned solely on limited observations. To generate samples from this posterior using the diffusion model, we first define the dataset. The notation X is used to represent the samples, where R is duplicated NP times, regardless of the number of contacts. This allows us to handle both single and dual contact cases with a single model. There are two types of observations. The first is related to kinematics, joint angles and position and orientation of the link frame. The second is related to contact force, external joint torque and external base wrench. Let us rewrite the posterior using the notation X. During the training process, the past single contact location XTS is not available. Our key idea is to sample XTS from the first contact point in the dataset by applying random KH step diffusion process. Intuitively, in the dual contact case, the diffusion model is trained to find both contact points, whether or not the first contact is provided. In the inference process, we utilize a contact state classifier to update XTS only in the single contact case. Considering a scenario where dual contact occurs sequentially, CDM initially generates samples without any information about the contact location. After the second contact occurs, the previous diffusion result is used, allowing CDM to generate samples with information about the first contact. Moreover, to guide the sample to be on the robot surface, we utilize signed distance field SDF network in the denoising process. We conducted a real-world experiment on CDM, which is experiment 4 in the paper. We used a Canova Gen 3.7 DOF robot equipped with a base FT sensor. The labeled markers shown in the figure were used to obtain the true contact point positions for evaluation purposes. Note that CDM does not rely on these markers. This is the experiment video for the single contact scenario. On the screen you can see the real-time output from the CDM. Next is the video for the dual contact scenario. When the contact state classifier detects a dual contact, the sample color changes to green. As shown in the video, CDM can localize dual contact occurring at arbitrary locations in any robot configuration. Thank you for watching.